Titration curves are graphs of pH and volume of titrant added to a sample during a titration. So essentially it's a way of following the pH as you would add your titrant into your sample. During a titration curve, the titrant is added past the end point, so past the point that you would normally stop the titration. It's the pH of the sample that's being measured as the titrant is being added from the burette. On these curves, you're going to see some areas of sharp rises and drops, and these indicate equivalence points in the reactions. These equivalence points are the places where the titration would normally end and we would start doing calculations. Indicators are always chosen for the titration for each titration so that the color change matches the equivalence point. So that's how we've always known to stop our titrations before, was when the indicator changed color. So what we're going to do in a titration curve is go past that equivalence point to see what happens to the pH if we continue on. On the screen, you'll see two graphs. The one on the left is labeled as a monoprotic sample. So mono means one, protic meaning a proton. So this is an equivalence point where only one proton has been transferred from the acid to the base. And if you look at the title that's with this graph, we should be able to figure out what the sample is and what the titrant is. Remember, the sample is in the Erlenmeyer flask and the titrant is in the burette. So in the title, we have 50 milliliters of 0.1 mole per liter sodium hydroxide titrated with 0.1 hydrochloric acid. The 50 milliliters of sodium hydroxide is the sample. Whatever we are titrating with, and that's the hydrochloric acid, is the titrant. That's what's in the burette. That also makes sense if you look at the pH. Remember, we would be using the pH meter to measure the pH of the sample in the Erlenmeyer flask. The pH has started off relatively high, around 13. So with a high pH, we must be measuring a sample that has basic properties. The equivalence point pH is right in the middle of where we see that sharp drop. So if you're following the curve, you should be able to tell that right in the middle of that sharp drop is around pH of 7. So you just read to the left. An indicator that we might use for this would be one that changes right around the pH of 7. So looking at your page 10 chart of acid-base indicators, there's a couple that you could pick. The best one would probably be bromothymol blue, which is HBB, or maybe phenol red, HPR. Looking at the second graph, this is called a diprotic sample because we see two different drops along that graph. So the sample that we're measuring the pH of has two proton transfers this time. So again, if we look at the title, 50 milliliters of 0.1 mole per liter sodium carbonate titrated with 0.1 mole per liter hydrochloric acid, we can tell that the sample is the sodium carbonate and the titrant is what we're titrating with, so that's the hydrochloric acid. And again, we started off with a relatively high pH, so it must be basic. And from your table of acids and bases, the carbonate ion, CO32-, is a weak base. The equivalence point on this is actually 2 points, because there's two places where we see a relatively sharp drop in pH. The first drop is around pH of 8, so right in the middle of that first drop. And the second one is on that second drop, and that's somewhere around pH of 4. So if you have a sample that's diprotic, so can accept two protons, there will be two equivalence points on your graph. when you would choose an indicator for this, or how you would choose an indicator, is to match up with the second equivalence point, so the second drop on the graph. For this one, it's around 4, so methyl orange is quite often used for this titration because it changes between 3.2 and 4.4, so it should span that equivalence point quite nicely. For this pH curve, you're seeing that it's starting low and you see a sharp rise. So for this graph, what we've done is change the sample in the titrant. This time it's a titration of nitric acid with potassium hydroxide. So the titration of nitric acid means that the nitric acid is the sample, that's HNO3, and the titrant, what we're titrating with, is the potassium hydroxide, KOH. And again, looking at the starting pH that's down around 0 means we must be starting with an acid. So of those two substances, it must be the nitric acid that's the sample. The equivalence point on this one, again, is right around a pH of 7. So something like, again, the bromothymol blue or phenol red would be a good choice. So the titration curves can either go up, starting from a low pH, or down. They can have one sharp rise, meaning there's one equivalence point, or one sharp drop, or they can show multiple equivalence points by having multiple areas of rising or dropping, depending on what your two sample and titrant solutions are.